we'll go ahead. We'll go ahead and get started here. A few more people coming in. We expect a few dozen people to join us, and we're joined here by our faculty directors and our staff. Yvonne, am I able to go forward, or do I need to cue you? Okay.
Yeah, I'm the one sharing the screen, so just say next.
Perfect. So welcome. Thank you for taking your time this evening. If you want to go to the next one, I'm Director of Engineering Executive Education, and we offer professional master's degrees for working professionals. And tonight we are going to try to keep our overviews fairly brief, about 10 minutes or so, 10 to 15 minutes for each program. And then when we get to the next steps and the Q&A, we'll put some breakout rooms in this session. So each of you can go into the breakout room related to the program that's most interesting to you. And the faculty directors and program coordinators will be available to answer more specific questions that you may have about the particular program itself. So we'll provide an overview at the beginning, and then during the breakout sessions, we can get into more specific questions that you may have. We're going to ask, just because of the size of the meeting, that you hold questions until the breakout session, so we can get through the information fairly quickly and leave as much time as possible open for specific questions you might have. Next. So by way of introduction, you'll hear from the faculty directors in a minute, but I wanted to point out and make some introductions to our staff. Yvonne Wu, Assistant Director of Engineering Executive Education, and also the Program Manager for Data Science and Engineering, as well as the Wireless Embedded System. And several of you have probably already spoken with Yvonne by email, and Stacy as well, as Program Manager for the Architecture-Based Enterprise Systems Engineering. Kristen is one of our operations and administrations professionals. She was unable to attend this evening, but those of you that joined the program and certainly our alum of recent years are familiar with Kristen. And Samantha Wong, also an administrative coordinator on the team, and just came on board a few months ago now. So we're happy to have Sam working to help administer these programs with us. So as you all probably know, the Master of Advanced Studies programs are part of the Jacobs School of Engineering at UC San Diego. Top-ranking engineering school with, I think, more than 275 active research faculty now, but the last time that was the number, and really committed to serving the needs of industry for the latest in research and education. I put some rankings information there if you're interested and want to learn more about the Jacobs School of Engineering rankings, as well as the department rankings. Next. And what I'd point out with all of our programs are, these are really partnerships and collaborations. Several of our departments in the Jacobs School of Engineering, computer science and engineering, electrical and computer engineering, mechanical and aerospace engineering, as well as other places on campus, including Rady School of Management, the Supercomputer Center, and Qualcomm Institute, and that's just to name a few. If we put all of our partnerships and collaborations here, would be able to read this slide very well. So these are all interdisciplinary collaborative programs across several different entities, including our companies and our corporate affiliates, and their input is valuable in making sure these degrees remain relevant and focused on the skills that practicing engineers find most critical. Next slide. this is a few of our different companies that have been represented in the program. Too many to keep putting on this slide, but well over 200 companies are represented, and we'll talk a little bit about the benefits of that and the cohort design of really your students, fellow students in these programs are all working professionals representing a lot of diverse areas and really a robust learning network, if you will. Next. So the Master of Advanced Studies is a degree that started in the University of California system as a way to distinguish between a thesis-based research Master of Science, focused on the research aspect as well as people continuing on to PhDs and so on and so forth. So I believe the University of California created this just to make it clear, and there's some differences as well. So instead of, doing a research thesis, our programs have applied capstone projects and just allowed us to be a bit more relevant in our pedagogical approach as well as our program design. Their professional degree programs, as I mentioned before, they focus on interdisciplinary areas, areas of emerging technologies, and so forth. Currently, we have 3 programs. Looks like people here are interested in the full spectrum here, and we have some more in development that we hope to share fairly soon. And our program design, regardless of the program that interests you, these are specifically designed to meet the needs of engineering and technical professionals to address the skills that are most needed right now by your companies, by you to do, to be a high performer, to manage teams, lead technical professionals. It focuses on that interdisciplinary, some would say multidisciplinary knowledge, and really optimized for working professionals. How many courses you're taking when, what courses are offered when, the schedule, and all of those areas, they're designed specifically for the needs of working professionals. We use a cohort design in all of our programs. So everyone comes in as a cohort. They work on projects, a lot of team projects, a lot of work together in that cohort design. And we really see the power of that learning approach. We have small class sizes. They'll be, generally speaking, no larger than 40 students. And on the smaller side, so around 15 to 20, and highly interactive and, again, application focused rather than necessarily deep diving into research focus. Next slide. So in your program overviews, you'll talk a little bit more about the admissions guidelines. I just wanted to make a couple comments. The first is the admissions committee, and that includes all of the faculty directors you'll be speaking with in a moment, really looks for fit. Are you at the right stage of your professional career to make the most of the program? Do you have the requisite background, knowledge, and experience to make sure you're successful? So it's really a holistic approach focused on whether you can be successful, and this will help you in your career. Generally speaking, we're looking at people with, at minimum, a bachelor's degree, although several students have other advanced degrees and participate in this program. There's a 3.0 minimum GPA. Again, there are some exceptions to the GPA requirement. Those generally are related to the amount of professional experience that you have and whether that's a really good indicator of your academic preparation. So although it's a school university minimum GPA, there are times where exceptions are warranted. And when we request those, we usually get them because they're for good reason. We do not require a GRE, and we do not require a TOEFL score if you've been working in the US for more than a year. The application fee is there. And generally speaking, in the program, faculty directors can speak more to this when they address you, but the typical work experience for the AESE program, Architecture-Based Enterprise Systems Engineering, is around 5 years. And that's just really one benchmark where you're at a point in your career where you're really able to focus on enterprise systems and drive change within your organization. And the wireless embedded systems and data science and engineering generally look at 2 years, but I'd say our average is probably a few more than that. We have application deadlines really just to keep some structure. We do accept applications on a rolling basis. We meet generally every couple of months to review once there's a good pool of applicants to review. So our February 8th deadline's passed now. So you have, looking ahead, April 5th, and then June 7th is our final deadline. We do review applications in the order received, but we do review them in batches as possible. And what we'll try to do, if you're ready to go and you need to have a decision before you can finalize your company funding or other things like that, just stay in contact with Yvonne and Stacy. If the timing doesn't work, we can always do some preliminary reviews ahead of time. So just keep those lines of communication open with Stacy and Yvonne and the faculty as you continue exploring about these programs. Next. Okay, this is a lot here, so I won't go through all of this. This is just to give you an idea of kind of the programs and their length, how many units you'll be typically taking in a given quarter. The faculty directors will address this more explicitly in their section coming up. Thanks. Program costs. So these are our per unit tuition. This is there's an asterisk there, really because every year we provide our rates to the University of California Office of the President, and the Office of the President is who sets the rate. And so we don't expect these to change. If they do, they may change only a couple dollars. And what you'll see is all of our degree programs are under $40,000 a year for when you look at just tuition. And there are also UC graduate student fees, the second asterisk down here. We put a link to that so you know exactly what they are. These won't be updated until about June for the upcoming academic year, so the 23-24 year. But again, this link at the bottom of the page will give you a good idea of what those fees are that are assessed to all graduate students at the university. I should mention those are your two fees, and the tuition and the fees is it. We don't have extra course fees. We don't have extra book fees or anything like this. You get all of your course materials, all of the software and the hardware that you need in your courses. We provide parking, free parking on campus, as well as meals when you're on your class day. Next slide. I'm sure all of you have taken a look at our website, so this is one of my closing remarks. Feel free to look through those resources on our website. Each program has its own microsite within our website, and we've tried to give you as much detail as we can to help you in making your decisions on graduate education. But if you ever have any questions that aren't addressed in these, do feel free to reach out to me, Stacy, Yvonne, and any of the faculty. with any questions you might have about the program and whether it's the right fit for you. Okay, and so in the interest of time, again, we'll have questions after. So we'll jump into our program presentations by the faculty directors. And at this point, I'll welcome Drs. Ryan Kastner and Fred Harris.
Okay, thanks, Gary. Let me know if you can't hear me. So I'm Ryan. I'm one of the faculty directors of the Wireless Embedded Systems program. And Fred is here too. He's the other the faculty director as well. So I'm a professor in computer science and engineering, and Fred's in electrical and computer engineering. Gary kind of mentioned that a lot of these or all these programs span across multiple departments, and they're very multidisciplinary, interdisciplinary. And certainly our program is that. And what we're trying to teach you how to do is build sort of the next generation Internet of Things, wireless embedded systems, whatever you want to call them, whatever the buzzy buzzword is of the day. But teaching you how to create radios, understand how signals are coming in, how to process those signals, how to build interesting systems around those wireless systems, so with sensors and actuators, put them in robots, put them in medical devices, all kinds of fun things. So, largely this has been driven by a lot of the interest in the San Diego area for these types of positions. So Qualcomm, for many decades now, but also more recently, Apple and a lot of the government agencies, contractors, Leidos and Northrop and the Navy as well. So we have a lot of students from the Navy that come and learn how to build next generation systems. So next slide, please. So, I kind of already talked to this, but the big picture here is the demand for these systems are growing tremendously. And that is driving a lot of innovation, but driving a lot of jobs into this area as well. So, many years ago, I used to kind of say, how many computers do we have in the room? Or, how many computers are we collectively using right now? And it's a lot, right? Especially on Zoom, doing things wirelessly or doing things, over the internet. And now you can say, how many sort of wireless computers do you wear on you? Do you take with you, a watch, a phone, maybe your laptop, maybe different types of sensors that you have on your body. So a tremendous amount, right? And this is growing at a really big pace, and a lot of different technologies are coming out. So a lot of different computing technologies, but also a lot of different wireless standards and wireless networking and wireless chips are coming out. Next slide, please, Yvonne. So this is really allowing us to build a lot of really cool and unique systems and make kind of old things that used to be not so great, maybe like cars, and put hundreds of processors in cars and wireless devices and have them talk to the satellites and revolutionize in the manufacturing and putting cameras everywhere and automatically detecting defects and wirelessly telling operators of these manufacturing lines where the defects are, and documenting power plants and so many different things, right? So it's really just driving a lot of different multidisciplinary applications. And what these companies are really looking for are people that understand many aspects of these systems, because that's how you really make these systems low power or fast or high performant. You really have to kind of understand top to bottom, and that's what we're trying to teach in this program. So we teach both, really software side of things with an embedded focus, so programming GPUs and embedded AI processors and microcontrollers, and also, a really deep focus on the fundamental analysis of wireless signals and systems in general. So you get a really nice mix of theory and practice. And you come out as really understanding sort of a broad swath of important topics in both engineering, electrical engineering, and computer science. Next slide, please. So this is kind of a cartoon picture of our curriculum. We have 9 classes. We have classes kind of both on the CS side and the EE side. So on the CS side, we have, an intro, high-level understanding of what embedded systems are. You learn to program in very low-level C, how to kind of get everything to coordinate and talk to each other. And then we have a class that's software for embedded systems, where you think about GPUs and FPGAs and all of these latest and greatest hardware accelerated devices and how to program those things. And a hardware for embedded systems class. So then you start thinking about hardware design and building, really custom systems, kind of things you would do maybe at Apple or Qualcomm. And then on the EE side, really a nice technical dive into sort of more of the theory and the applied theory of signal processing and how to use that to build up communication systems, and then build wireless systems on top of that, but also understanding the network aspect of these devices. So what is LoRa, and what are some of how does wireless work? How does your Wi-Fi work, right? These sort of questions, and how do you use that, more importantly? So how do you get a device that you can buy for $100 and use that to do something interesting, right? And that's really what the capstone class is. At the end of the program, you come up with your own idea and you build an interesting project and demonstrate that project for your cohort and also previous cohorts. A lot of our previous students come and kind of watch and understand what you've done and give you feedback on that. So it's a real focus on building systems, applied systems, but also, like I said, a deep understanding of the theory behind a lot of the signal processing aspects of wireless embedded systems. Next slide. So that was the pictorial view, and this is now the kind of the time view. So what we do is we try to stagger these classes out as evenly as possible. In the first year, you kind of go back and forth between signal processing and embedded systems. And then in the second year, you have a couple of classes that go together. So the first year is all one class, including the summer. And then in year two, you have two classes that are designed to work together, and then it finalizes in your final quarter with a capstone project. Next slide, please. So that's all I got. Yvonne can tell you all about the technical or more of the other details, but I'm also very happy, Fred and I are very happy to answer your questions in the chat room later.
Thank you, Ryan. So just really quick, Gary kind of touched upon this, but I wanted to kind of touch on the wireless embedded systems admissions guidelines. It's preferred to have a bachelor's degree in engineering, sciences, physics, math, etc., but it doesn't have to be. 3.0 minimum GPA is a university requirement, but there are exceptions that can be made. A statement of purpose. The WEST program does require 3 letters of recommendation, resume, and there's no GRE requirement, or yes, required. When it comes to the letters of recommendation, as long as you've submitted who the recommenders are, you can go ahead and submit your application, even if the letters haven't been uploaded yet. But we do recommend that they come in as soon as possible, close to the deadline, so that your application can be reviewed shortly after that. And I will now introduce the faculty director of the Architecture-Based Enterprise Systems Engineering Leadership Program, John Wade. I will hand it over to you to talk about that program.
Thank you, Yvonne. Thank you for giving me a chance to talk to this group about this program. So it's the Architecture-Based Enterprise Systems Engineering Program, and it's really focusing on the big picture and how you translate that big picture into capabilities and into action within the enterprise. I'm the faculty director. The audience, as we mentioned, is our engineers with 5+ years of relevant professional experience, although we've had students who have had less experience than that. This is a 1-year program, so it's an intensive program that starts in September and it ends in August. We meet on alternating Fridays and Saturdays, and there's a 4-day workshop per quarter. This is a joint program between Rady School, in particular, the Rady School and the Jacob School, and particularly Mechanical and Aerospace Engineering and the School of Management. Next slide. So we're in a different place than we were in the past. We're entering, you might have heard, Industry 4.0, which is it's a time when it's really, as you've heard from the last speaker, it's a networked world. Systems are far more complex than they've been in the past. Systems engineering in the past was focused on mechanical systems and then electrical systems with islands of software, and then software intensive systems. And then things became network intensive. And now we've moved into sort of the enterprise where we have systems of systems working together. And the approaches that are necessary to be successful in this environment are very different than the ones that were successful in the past. This program was created to meet those challenges. Next slide. So the transition in systems engineering is moving from systems in the past that were built to last, that are systems that are built to evolve, from opinion-based decision-making to model and data-driven decision-making, to paper-based documentation to model-based documents, deeply integrated architectures to modularized ones, hierarchical organizations to ecosystems, satisfying requirements to constant experimentation and innovation, phase-based verification validation to continuous verification validation, and sort of separated development and operations where those are now becoming integrated. So it's a very different world that we're working in now in systems than we have in the past. This program reflects that change. Next slide, please. We've talked a lot about digitalization, and it's really about extracting value from data. And the point of it is to take data that might have originated from observed data. Maybe it's from simulated data. Maybe it's experimental data in those two areas. But the point is to be able to take that data and to be able to make decisions and act more quickly, to observe, to orient, to decide, and to act. And the companies that do this well are the companies that are the most competitive on the planet. And so the program is really focused on how do we create enterprises that are learning enterprises, that are able to accumulate data and again, observe, orient, decide, and act more quickly than their competitors. Next slide. So that's what the architecture-based enterprise systems engineering program is all about. Again, it's a collaborative program between the Rady School and the Jacobs School. And we focus on a lot of systems thinking types of things where you're really looking at the big picture, at the larger ecosystems. How do those ecosystems sort of play together? What are the large factors both inside your company and outside your company with respect to competition that are sort of driving change? And how do you take all that together along with technology to create infrastructure, organizations, strategies, and tactics that enable you to be more competitive? Next slide, please. So we've taken a lot of things, a lot of the sort of information age, components, I won't read them off, and coupled them together in systems of systems, and we're really focused on the integration of all those elements. So you're not going to be creating code and writing code and developing technology per se, but in this program, you're going to be figuring out how to put it together, how to integrate it most effectively to achieve the strategic objectives of your organization. Next slide. The curriculum comes in, as I mentioned, it takes place over a year. And then the fall is focused on leadership, goals, strategy, finance, accounting, complex systems, agile development, DevOps. It's giving you sort of the systems thinking side of things, the big picture. In the winter, we focus on the systems development, enterprise architectures, architectural frameworks, use cases, capabilities, domain modeling, service-oriented architectures, and governance, functional and physical architectures. In the spring, we're focused on decision systems, decision-making, the metrics with respect to performance, metrics with respect to effectiveness, event-driven architectures, the art of decision-making, data analytics, and the like. And then finally, in the summer, we pull all those together and you have your capstone project. And so you'll be doing a presentation in the end of the summer that pulls all these pieces together. And so there's this project that goes through the entire program. And so in each of your courses, you'll be spending time working on that project. There won't be any busy work in this program at all. It's really all focused on your projects and the work that need to be done. And those projects tend to be important projects within your organization. So many of the cohorts are based within companies or across companies in such a way that you can work on real problems in your enterprises. Next slide, please. So these are going to be complex adaptive systems, and development of these systems really happens through synthesis rather than analysis. It's not possible to just define these a priori. And our learning and experiences are similar. We believe that you'll get about 10% of what you need to learn in the classroom, 20% mentoring and coaching, and most of that is going to be working through your projects and actually doing the work. And so we'll be working with you on that. Any questions or comments or issues that you might have, be happy to work with you through that process. So our teaching is very much follows that same mode of learning by doing. Next slide. So some of the capabilities are understanding the enterprise landscape, involving yourself with the stakeholders in your within your enterprise, defining goals and missions, identifying the desired capabilities, the different architectural models, and then iterating through this based on experimentation and iteration. And what we've seen is the graduates from this program become the leaders and the team builders within their organizations and enterprises. Next slide. So again, this is a one-year program starting in September, ending in August, following the same framework as the others, Fridays and Saturdays alternating. There's, again, 1 4-day workshop per quarter from 9 a.m. to 6 p.m. Breakfast, lunch is provided. The courses are offered sequentially. So there's 3 courses in each of the three quarters. And then there's just the project in the summer. Next slide. Stacy, it's all yours.
Thank you, John. Appreciate it. My name is Stacy. I'm the program manager for the AESE program. Similar to Yvonne's 2 programs, the AESE program does like to see an undergraduate degree in a STEM field, but we have had applicants and alumni with non-STEM degrees. I think we've even had somebody with a music degree, but we take a holistic approach when reviewing your application. So degree is just one part of the picture. Similar to GPA, we can be flexible with that, but a university minimum is a 3.0. A statement of purpose is pretty important. In your statement of purpose, you would want to state what you hope to get out of the program, what you can bring to the program. 2 letters of recommendation. We do like to see 3 though. 5 years relevant work experience, but as John mentioned, we can be a little bit flexible there too, depending on the other components of your application. An informative resume, and we do not require a GRE. Next slide. So I'd like to introduce Dr. Aline Deutsch to present on the Data Science and Engineering program, and Dr. Altintas as well.
Hi, everyone. Welcome. Thanks for the opportunity to share with you the details of our Data Science and Engineering program, which is a collaboration between the San Diego Supercomputing Center, represented among the faculty directors by my colleague, Dr. Ilkay Altintas. She's the Chief Data Science Officer there, and she has done active research on projects with real data, large data requirements. And the Jacobs School of Engineering, in particular Computer Science and Engineering, I'm the faculty director representing that department. I'm a professor researching data management and database techniques. The intended audience of our program is engineering professionals with a background in some technical engineering field, mathematics, statistics, and some experience in data analysis. The program is a 2-year program going from September to June, with classes on alternating weeks. On teaching weeks, you will have classes all day, Friday and Saturday. The mission of our program is to allow you to manipulate data and draw insights from it. And nowadays, this is no longer an exercise in opening an Excel spreadsheet and looking at it and deriving trends from it. Data have become simply too large for that. You need to attack it with much more sophisticated tools, given that already what we call big data has been evolving and is continuing to evolve according to Moore's exponential trend. And at this point, we're talking about petabytes and exabytes as routine sizes of data that is output, for example, petabytes by the Large Hadron Collider at CERN, 1 petabyte per second, and the internet creating 1 exabyte of data every day. The trend will only accelerate, and therefore the question is, what should data scientists learn in order to deal with this flood of information? Could I have the next slide? This is the vision of our program. We believe that the education of the data scientist resides on these 3 important pillars: math and statistics knowledge, domain expertise, and programming skills, which we call here tongue-in-cheek hacking skills. And we believe that the data scientist resides at the intersection of the 3. Notice here that for each pair of intersecting domains, you will get some of the more traditional backgrounds. For example, if you have the expertise in the math and statistics knowledge, that is going to be sufficient for traditional classical research. If you know how to program and you have the math and statistics knowledge, you are a machine learning scientist. The big danger zone that is currently hitting many data science amateurs is when you know how to program and you have the domain expertise, but you're lacking the math and statistic knowledge, and therefore you don't really know what to make of the results of applying certain pre-existing machine learning algorithms as black boxes. Can I have the next slide? Our philosophy is implemented in this curriculum. Notice on the top you see the courses in the first year. We start with making sure that everybody is comfortable programming, and of course the programming exercises and projects will be targeted at data analysis tasks. There will also be this DSE 290 that you see there is a series of 1-hour invited lecture talks that will tell you about real case studies appearing in industry. They will be given by alumni, but also industrial visitors, usually from the greater San Diego area. And you will get a good idea on how data science is being used in their company. In many cases, if they are our graduates, how they changed their career and became data scientists after our program. You will get to network with them. You will hopefully get to send them resumes and just get a feel for what the industrial needs are in the field. This will happen basically every teaching weekend. In addition, there will be a lot of emphasis on manipulating data, storing it, massaging it into a form that you can use to run machine learning tasks over it. It is well known that in an analytics task, 80% of the work resides in just preparing the data. And that's why we have courses that teach you how to use data management systems, such as DST 201, how to take data from various sources and integrate it and transform it, prepare it, such as DSC 203 in the fall of year 2, how to manipulate data that does not come in the form of standard relational tables, such as DSC 250. There is a lot of emphasis, of course, on the probability and statistics pillar, DSC 210, with very specific applications where you would also program to perform your projects using typically Python. There is emphasis on platforms that allow you to work on huge data sets in parallel. This is DSC 230 that looks at Hadoop and Spark and other such tools of the day. And everything will be tied together with, let me not forget, of course, the machine learning course, DSC 220, which is really what we're building up to. Everything then will be tied together with a capstone project that covers 2 quarters in year 2, and which my colleague Ilkay is the head of. She can answer your questions there. We have seen extremely interesting projects in this course. Projects which, when you present as a team, you will also benefit from our DSC 241 course, which teaches you how to visualize large data sets and trends and so on without cluttering the screen and in ways that are intelligible to somebody who does not have data science credentials, such as your manager. All right, I think that's all I wanted to say. The floor goes to Yvonne.
Thank you, Aline. So I'm just going to go over the admissions guidelines for the data science and engineering program. A lot of it is very similar to the other 2 programs, so I won't repeat most of them. I think the main difference is the DSE program has 2 letters of recommendation required, but 3 is preferred. Everything else is pretty similar to the other programs. The other additional thing I did want to mention, there are some additional guidelines for the DSE program. The application for this program does include 6 additional questions that are asked that kind of gauge your background and experience with data science. What the faculty directors are kind of looking for are your programming experience, if you have experiences with databases, SQL, experiences with data analysis in an application domain. Some other things that may help strengthen your application are also your math background. Aline had mentioned, probability and statistics as being very important, linear algebra. If you have experience with distributed systems such as Hadoop and Spark. These are some of the things that they also look for when it comes to the questions that are on the application as well. So with that, I'm going to continue on to the next steps. So the next steps for all of our programs, you can find any of this information on our website listed there. Stacy and I are the program managers, and we are happy to answer any questions that you have. Feel free to email us at any time. Our email is listed there. We are accepting applications now. They are being reviewed. We have our next application deadline, which is April 5th. And so do not hesitate to reach out to us if you have any questions. But if you do have questions right now, I will open up the breakout rooms. There are 3 rooms, 1 for each program. The faculty directors will be in there, and you can go ahead and join, ask your questions, and you can feel free to leave once your questions have been answered. You don't have to come back into this main room, or you can even hop into another program if you're interested in more than 1 program. So I'm going to go ahead and open the rooms, and you guys can all jump into the breakout room of your preference. There you go. And thank you for joining.
Yvonne, how do we get into the breakout room? Remind me, please. Oh, there they are. She just showed up. Okay, I see it now. Thank you.